gain or release or gain heat energy H or Q equal mass of that object into specific heat of element or object into change in temperature theta del theta. That means an object can release or gain heat Q or H equal m s del theta. Here m is the mass of that object, s is the specific heat of that object, and del theta means change of temperature. Suppose here a iron bar, this is an iron bar, iron iron bar, and near it another iron bar kept. Okay, this is another iron bar, and the temperature of this iron bar is 80 degrees Celsius temperature, and this iron bar is only 30 degree Celsius. If we keep these two iron bar close to each other, then this iron bar, that means 80 degrees Celsius temperature, and this iron bar is 30 degrees Celsius temperature. This iron bar will release heat and it will gain heat, and it will continue till they are balanced. They come in equilibrium state. Okay, that means the temperature of this iron bar gradually decrease and temperature of this iron bar gradually increase at a certain temperature. Suppose the temperature theta c, the equilibrium state, when they come equilibrium state, that means both iron bar contain same temperature, that is the theta c. Okay, so we can say that how much heat energy a substance or element will gain or release, it will be mass of that substance and specific heat of that substance and change of temperature. Okay, thank you. Okay, ice can receive heat or ice can gain heat in 2 or 3 steps. Ice can gain heat in 3 steps. Okay, if the given temperature for ice within minus sign, number 1, when given temperature within minus sign, that means minus 2 degrees Celsius temperature or minus 5 degrees Celsius. Okay, then heat gain by the ice Q1 equal mass of ice into 2100, that is the specific heat of ice, into given temperature with positive sign, given temp with positive sign. Okay, step number 2. Now the ice at 0 degree Celsius temperature and the state is solid state. Now heat gain by the ice of 0 degree Celsius to go to go 0 degree Celsius, water. Heat gained by the ice of 0 degree Celsius to go 0 degree Celsius, water, melt water. Okay, so Q2 will be MLF. MLF, that means mass of ice into latent heat of fusion of ice. Okay, so it will be mass into the latent heat of fusion for ice is 334000 joule. Okay, this is the gain heat by the ice when it go solid state to liquid state. Again, step number 3. Step number 3. Heat gained by the heat gained by the ice to go 0 degree Celsius temperature, water to mixture temperature, mixture temperature. Okay, and the heat will be Q3 equal mass of melt ice or water into 4200, this is the specific heat of water, into change of temperature, that will be the water was at 0 degree Celsius and it will go to mixture temperature, and that is the theta C. Theta C is the mixture temperature here. So theta C minus 0 degree, and that will be M into 4200 theta C. In this way, in this 3 way, ice will gain heat. Okay, now we will do a problem, solve a problem. Okay, there is a problem. You can see a beaker here with 3 kg water, and the temperature of this water is 30 degrees Celsius, and beside it there is a ice bar, and the temperature of that ice bar is minus 2 degrees Celsius, and the amount of ice is 500 gram, that means half kg. Okay, so our question is, what is the mixture temperature? If we mix ice with this water, then what will be the mixture temperature here? Okay, now we will solve this problem. First of all, we have to decide who will gain heat here and who will release heat here. Okay, so we can see the water of 30 degrees Celsius temperature, it will release heat and ice will gain that heat. Okay, so we don't know what is the temperature of this mixture. So let the temperature of the mixture is theta C. Okay, theta C. So here ice will receive or gain heat in 3 steps. Okay, first step is, we know the first step is here heat gain by the ice Q1 equal the ice at minus 2 degrees Celsius temperature. That means the first step will be the amount or the mass of ice 500 gram, that means 0.5 kg, and specific heat for ice is 2100 here, and the given temperature is minus 2 degrees Celsius, it will be positive 2 degree Celsius, that means 0 minus 2, and that will be 0.5 2100 into 2 2100 joule. Okay, that is the gain temperature by the ice to come at 0 degree Celsius solid ice. That amount of heat it will gain. Now the ice at 0 degree Celsius temperature. Okay, this heat gain to come at 0 degree Celsius solid ice. Okay, now step number 2. Now the water, now the ice at 0 degree Celsius solid ice, solid state. Okay. Again, heat gain by the ice, by the ice uh, become 0 degree Celsius water. Heat gain Q2 equal mass of ice 0.5 kg into latent heat of fusion, that is 33400. That means the formula we will use here, mass into latent heat of fusion. Okay, so it will be 0.5 into 33400. Again, heat gain by the ice to go at the mixture temperature. That means heat gain by the ice to go mixture temperature from 0 degree Celsius water. Okay, Q3 will be mass of ice is 5.5 kg and specific heat of water, because now the state of ice at liquid, that means water, so we have to use their specific heat of water into the change of temperature will be, it will go 0 to theta c, that means theta c is greater here, theta c minus 0 degree Celsius, and that will be 2100 theta c joule, and this 3 way the ice will gain heat. Okay, now for the water, for the water will release heat here, and what is the amount of release heat by the water here, we have to calculate it now. So that is Q1 2100 joule. Okay, now heat released by the water, heat released by water Q4 equal mass of water, mass is 3 kg here, and specific heat of water is 4200, and change of temperature is 30, it will go 30 to theta c, that means 30 is greater here, 30 degree Celsius minus theta c. Okay, so this is the amount of released heat by the water. Now according to calorimeter's principle, we know heat gain equal to heat release, and we can see here ice gain heat in 3 steps and only water release heat in 1 step. So according to calorimeter's principle, we can write now Q1 plus Q2, that means the gain heat, Q3 equal Q4. Okay, put the value here. So for Q1, we know here Q1 is 2100 plus Q2 is 0.5 into 33400 plus Q3, and Q3 is 2100 theta c equal Q4. Q4 is 3 into 4200 into 30 minus theta c. Okay, so calculation this equation and you will get the mixture temperature theta c. Now calculate it. Theta c equal 20,8900 divide answer 14.2111 degree Celsius. The temperature of mixture will be 14.211 degree Celsius. Okay, and that's all. Okay, yeah, of course.